Hey everyone, and welcome back to The Explainer. Okay, we've got a lot to get through today, so let's just dive right in. We are unpacking a highly technical, but honestly absolutely fascinating status report. It's the SFH-SGP post-Phase 6 development state. Now, if you've been following this specific neural structural framework with us, you already know Phase 6 was a massive, monumental hurdle. But looking at the post-Phase 6 landscape, wow, things have shifted dramatically. We're actually moving past theoretical postulating and straight into the realm of hard, undeniable structural constants. And I am so thrilled to walk you through exactly what these new developments mean.
But first, I want to pose a quick question, just to get us all properly oriented. What happens when artificial intelligence starts developing its own laws of physics? It kind of sounds like a hook from a sci-fi movie, right? But seriously, I want you to keep this thought in the back of your mind as we go through the material today. Because what we're looking at isn't just some routine patch note or a boring developer update, it's actually a thrilling scientific mystery hiding right there inside the architecture of the system.
So let's look at Section 1 of the post-Phase 6 state, the locked empirical law.
Take a second to really appreciate the gravity of that phrase. The developers were incredibly precise with their terminology here. You see, an empirical law is a rule based strictly on observation and experimental evidence. It isn't just something derived from pure abstract mathematical theory that, might look good on paper. It's something we actually see happening, consistently and repeatedly, right there in the data. And to say this law is now locked in the SFH-SGP structure, that sets incredibly high stakes for this update. It means this isn't a statistical fluke. It is a verified, permanent, and observable reality within the system's framework.
Okay, moving right along to Section 2 of the report, validation or testing the domain.
So, where exactly does this empirical law live? I mean, we can't just go around claiming a law exists without actually proving where it holds true. Well, the report explicitly states the testing domain. It's been validated in MLPs, multi-layer perceptrons. Now, for those of you familiar with network architectures, you already know MLPs are the foundational, feed-forward artificial neural networks. They're literally the bedrock. And that's a really crucial detail because it tells us exactly what kind of environment this structural constant requires to manifest. It's happening right inside that classic multi-layered architecture. And honestly, this just brilliantly illustrates the rigorous testing behind their claim. They didn't just test this in a vacuum, and they didn't just test it on one narrow set of parameters either. It was proven across some highly specific, rigorous data sets. On one hand, we've got standard MNST, the absolute classic benchmark database of handwritten digits that everyone uses to train image processing systems. And on the other hand, we have Fashion MNST, which is a much more complex dataset dealing with articles of clothing. The takeaway here, this empirical law held up consistently across entirely different image classification benchmarks. It completely proves that this locked structure isn't just, memorizing one specific type of data. It's a fundamental underlying constant within these networks.
All right, let's shift gears and look at Section 3, current boundaries and constraints.
Now, as hyped as we are about this breakthrough, and we definitely need to put our scientific skepticism hats on for a minute. An empirical law is amazing, yes, but it isn't boundless. The post-Phase 6 report outlines 3 very specific, hard boundaries that box this law in. Number 1, it's operator-dependent. Number 2, it is not globally invariant. And number 3, it features weak or even zero interaction terms. I really want you to absorb those 3 points, because while the law is absolutely observable, it only operates within these incredibly strict mathematical boundaries.
Let's translate that a bit to see exactly how it limits the system. When the report says the law is operator-dependent and not globally invariant, what does that actually mean for us? Well, basically, the rule changes or completely breaks down depending on the specific mathematical operators you're using. And it definitely doesn't hold true universally under all global transformations. So as you can see, this severely limits the current universality of the SFH-SGP structure. It's a localized rule, tightly bound to the exact way the neural network is currently set up. It's not the theory of everything, at least not yet.
But I want to focus your attention on that final constraint, weak or no interaction terms. This is such a fascinating limitation. It tells us that the components governed by this empirical law are, for the most part, acting completely independently of one another. They aren't tangling together or influencing each other in complex ways at this stage of development. It's actually a beautifully simple, isolated phenomenon, which, on one hand, makes it way easier to observe and verify. But on the other hand, it marks a definitive, hard limit on how the structure actually behaves right now.
And that brings us beautifully into Section 4, the ultimate open question.
Let's just quickly recap. We've got a verified empirical law, validated in MLPs across MNIST datasets and bounded by very specific mathematical constraints, right? Okay, now let's take a huge step back. It is time for what I like to call the microscope to telescope transition. We're zooming all the way out from the strict constraints of computer code and looking at natural philosophy. Why should we actually care about this? Well, what if it's bigger than AI? Seriously, this isn't just about tweaking an algorithm so it classifies pictures of shirts a tiny fraction of a percent faster. This connects lines of artificial code with the fundamental fabric of reality itself.
The post-Phase 6 report actually leaves us with this massive exact quote: "Does this structure exist outside neural systems?" Just let that hang in the air for a second. The researchers are staring at this mathematically constrained, operator-dependent empirical law, and they are openly wondering if they've stumbled upon a pattern that exists in the natural world. Think about it. If a neural network processing pure data naturally locks into this specific structure, does that mean this law is a fundamental property of information processing everywhere?
So is this a universal structure? That is the profound, wide-open question we're left with today. We started this explainer by looking at code, validating against standard datasets, and analyzing math constraints. And we end up questioning the very architecture of our universe. Are these artificial neural systems just mimicking a hidden law of physics? Or did they literally just organically discover one? Keep that question squarely in your mind as we wait for the next phase of development. Thank you so much for joining me on this explainer, and as always, keep learning.